Fernando Ferreira from Wharton School, talking about real estate markets. Go ahead.
This paper is about estimating preferences for neighborhood amenities under imperfect information, and this is joint work with Professor Maisy Wong. It's my colleague here at Wharton. And perhaps this is the most important slide that I have, which is the motivation for the paper, explains why we're doing it, and we spent a lot of energy, a lot of time in this project. And the most important idea is that the neighborhoods are really critical for the well-being of everyone in this call, and all adults and children. And I'm citing here, and I'm not sure if you can see my pointer here, but I'm citing several papers in the economics literature, and they're about a number of topics, such as how pollution affects quality of life, and pollution usually is very localized, sometimes by neighborhood. And I have my own paper about how school quality is really important for people, and they care about the neighborhoods also because of the peers that live there. There's other work about the networking that happens in neighborhoods that help people get jobs, work about crime, about racial segregation. That's a major topic in the United States. And more recently, this work by Chetty and co-authors about how neighborhoods provide a variety of different quality of opportunities for children, and that has major impacts on long-term outcomes. In addition to any, neighborhood characteristic that you think is important for you, such as bars and restaurants and friendships and commuting and so on. So neighborhoods are critical for all those things, and economics have a gigantic literature on all those topics. However, and that's my second bullet point, there is also separate literature trying to understand and estimate the importance of all those factors in how people choose those neighborhoods, how household sorting happens. And this literature has a number of models that, we estimate this model using the best data available. But as you know, there are lots of assumptions that we needed to impose in order to make those models tractable. And perhaps one of the most important assumptions is that people have perfect knowledge about those neighborhoods. And by perfect knowledge, I mean that they are aware of all those neighborhoods, and they're perfectly aware of the quantity and quality of all those amenities that exist in all those neighborhoods. And can you guys hear me, by the way? Good, thanks. So as you can imagine, that's not a realistic assumption. Even I work in this area, and I have access to all the data, and I have access to all those models, and I don't know, I only know a fraction of what's going on in my own neighborhood, and so which is a problem. Now, I'm guilty of using this assumption. I have papers. My co-author Maisy has papers that use that assumption because it's a quite convenient assumption, and I'm pretty sure you all use that assumption in your models as well, for different subjects. And I'm citing this other literature here that I'm not sure again if I can see the pointer, but this discrete choice literature, which is applied to many other settings, not just neighborhood choice, but choice for cars, choice of yogurt, and anything that any kind of a product that you can think of. They also use that assumption for the most part. Now, the problem is we have a setting that's extremely critical important, and we have a whole literature that have been using assumption that's not credible, because imperfect information, that's my last bullet point here, is likely pervasive in the setting of neighborhood choice. Because it's just, again, it's just difficult to acquire and process this information about hundreds of neighborhoods in a metropolitan area, and potentially, hundreds of thousands of amenities, such as prices, demographic composition, school quality, safety, housing stocks, sidewalks, trees, and bars and restaurants, and so on. So we basically in this paper try a first shot at writing down a model of neighborhood choice of imperfect information and getting the data to estimate it. It's almost like a proof of concept that this can be done, and that actually matters. So that's what we do in this paper. There are 4 parts of this paper. I'll try to cover everything today. The first one is we'll show this model. It's a very simple model that allows for individuals to have imperfect information about every amenity in every neighborhood. It's going to be a very general model. The second bullet point is we're going to apply this model to a new data that's based on a neighborhood choice program. So we developed a program in partnership with a large professional school to actually help students that are graduating choose where to live. And this is a pilot program, and we provided information about amenities to help them choose where to live. Those are the students in a professional school. They're about to graduate. They already have jobs. They know where the city that they're going, but they're in the beginning of the search process, okay, for neighborhoods. Then with this data from this program, we estimate this model, and we show that we can address this unobserved neighborhood quality that varies by individual. It's a really complicated problem. It's related to imperfect information at the individual level. And we're going to construct this sufficient latent quality index that will deal with this imperfect information problem that will bias our estimates. And after all of that, we'll present estimates of this model. And as a proof of concept, we'll show that we can recover 2 important parameters of this model, which is this marginal utility for rents and marginal willingness to pay for one amenity only, which I'll describe this amenity in a second. But before I move forward, do you have questions about any of this?
Fernando, maybe you'll talk about this later, but how do you know more information than the graduating students do? So like I imagine, so like when I think about collecting information on US neighborhoods, I would like Google stuff, and there are websites that curate a lot of information. Mm-hmm. Do you like increase exposure of students to that, or do you create like new databases? How is that done?
Well, as you're correct, in practice, people use a variety of methods. So for this particular set of the school, we did a lot of qualitative interviews with the students and with the school, because the school was worried about this issue. That's part of the motivation too that I'm going to talk about in a second. The school was really worried that even though there are countless websites, most students were not really doing a good job searching for that information, and they're not doing a good job processing that information. And for the most part, they relied on informal networks to gather the information. And by the informal network, let me be more precise, they had one friend that lived in one place, and the friend said, "Oh, I think this neighborhood is good because of something." That's how a really large fraction of people gathered information about the neighborhoods. Now, this could lead to all sorts of biases in this particular setting of the professional school, because the school realized that the students had a really bad way of thinking about this. They're thinking like, well, I really need to choose the best, which for them meant the most expensive neighborhood in New York to live. Most students of this school go to New York to live. They get jobs there and they will live in New York, which is a problem because, upon graduation, you don't make a lot of money, and if you think you can only be successful by living in the most expensive neighborhood in that town, that's a problem. You're setting yourself for failure. So what we did in this program that I'll describe in more detail in a second, in a few minutes, is to ask them first what they knew, and then provide this particular type of information about the rents and about this amenity that will focus is is the same school, professional, and social network. And for this particular setting, we're able to gather new information about that. The students, it was really hard for the students to figure that out. But I'm going to describe in more detail the information that we provided for them and how they reacted to that information.
Super cool. Thank you.
You're welcome. Any other question on where we are going? Okay, so again, feel free to interrupt me as much as possible, because I also don't know how much background you have about all this economics literature, and it might be too easy or too crazy, or maybe it's just a terminology might be different than what you're used to. So this is the neighborhood choice model. So Luna, can you actually see my mouse here pointing to a equation? Oh, that's great. So so we call the utility of individual Y choosing a neighborhood J. So this utility is unobserved. Okay, it's a latent variable. But what the models assume is that people observe this omega, which is a C-dimensional vector with all amenities in a neighborhood. Okay, you think about a really high dimensional vector here. And perfect information assumption means that all those amenities are perfectly known by all individuals. Okay. Now, the individuals have preference for those amenities, and that's those beta parameters here. And I'm not showing you the functional form for this, but think that every single individual can have heterogeneous preferences for those amenities. Later, we're going to make this a function of their demographic characteristics. Okay. And in economics, there is an error term, and we use this standard assumption from the literature. This error term is type 1 extreme value distribution. And this distribution is part of those choice models that I talked about before. I'll come back to that a bit later, okay, when talking about the estimation. Now, this is a simple but very hard model to estimate. And we're going to make it a bit more complicated by allowing for imperfect information about that omega J. And we're going to do it in a simple way by allowing every single individual to have a different delta omega ij, which is how much each person knows about every neighborhood amenity. Okay, we are making this model a lot more general by the virtue of adding this term. So think of it of every person has a little error, a little variation over the true omega j, and this delta omega j varies by each person. And when this vector delta omega j is the null vector, we're back to the perfect information situation. Okay?
Do you have to assume a question? Do you have to assume constraints on omega, the delta omega, like the perturbations are homogeneous more or less?
Right now, we are not making any assumption about omega j and about the omega j. We say omega j is everything that's in a neighborhood, and delta omega j means every person knows omega j in a different way. It could be because of more information. It could be because of less information.
Right.
It could be because of behavioral biases. It could be by perceptions. It could be a number of reasons that different people have different errors or different perceptions about those neighborhood amenities. So at this point, this model is so flexible that allows for everything. Okay, now this is from the perspective of people choosing neighborhoods. Is individual utility. I haven't talked about the researchers yet, and researchers like us in economics, we call them econometricians. And that's another pickle here, because the econometricians only observe a limited number of amenities k. So instead of observing the omega j, the econometricians only observe k amenities. Okay. So think of what we observe is our data sets. Our data sets in general are limited. And we only observe this k amenities, and I'm calling xj. And let's assume that we researchers observe k, and k has a smaller dimension than c. Okay, c is all amenities, k is what we econometricians observe. And now, what we do not observe, we econometricians, I'm going to bunch everything in this term xj. And think about this xj is an unobserved neighborhood quality index, because it's everything else that we econometricians cannot observe. In this literature, they tended to bunch these unobservables at the neighborhood level, at the j level. So now we have this situation where we only observe this data here, xj, and we have those two unobserved components here, the xj at the neighborhood level and those delta omega j's.
Sorry, what xj means again?
xj is our data set. So you're the researcher, you're going to estimate this model, you only observe those x characteristics. Let's say you observe price and you observe crime. So that's going to be your x variables. The variables that you do not observe, let's say you do not observe the type and quality of trees and the sidewalks in a neighborhood, that's part of this unobserved neighborhood quality.
I see. So in this equation, which parameter is learnable? Or I see this equation is much like the linear regression model, but I assume this is different, right?
Yeah, but this point of perfect information applies to a linear regression model too. You just change the error term to the regular, linear regression error term, and it's exactly the same thing. There are variables that we observe and others that we do not observe. And just to simplify the notation, I'm bunching all of them in this unobserved quality index.
I see.
And in the standard identification problem of this model is that the covariance of the x that we observe and the xc that we do not observe is different than 0. And because it's different than 0, all the betas that we estimate are biased and could be biased in a number of directions, okay? Depending on the variable, depending on the situation. Now, this is the standard bias, okay? This is a standard econometric identification problem, and there are many ways of dealing with that. Instrumental variables, experiments, randomized control trials, regression discontinuity, a number of strategies. But all those strategies still assume perfect information. They do not assume imperfect information. Those strategies do not deal with this other term here, the delta omega j. And in this model that's more general, have this new identification problem, because there is a covariance of what we observe, let's say price and crime, with those delta omega ij, which is a really complicated term, this delta omega ij here. Let me give you some examples of how this can create bias. Let's say some individuals may think expensive places, expensive neighborhoods like Tribeca in New York City, have better schools than the actual measures of the school quality in Tribeca. Okay, that's a problem. While other individuals may think that Tribeca has better trees than they actually have, just because, hey, it's Tribeca, everything must be golden, have streets paved with gold in Tribeca because it's so expensive, And if people think about that, even without knowing, that's a problem. It creates this covariance that's different than 0, and it's going to bias our estimates. Now, another example is some individuals may underestimate rents in expensive neighborhoods. It could be like that, you know, Tribeca is extremely expensive. I'm gonna show you the data in a second. 99% of the people never lived in Tribeca and never set a foot in Tribeca. And because of their perceptions of it's a fair price or average price, they just think that the price is much lower than it is. While other individuals may actually overestimate rents in cheaper areas because of the same problem. They're so used to those expensive neighborhoods in New York, in Manhattan, that may think that even the cheaper neighborhoods have higher prices. Those are just examples that those covariances here can assume so many forms and really bias the estimates in a way that we're just not aware of. And part of it is because the multidimensionality of those neighborhood amenities, and every single individual can think about those amenities in a different way. Okay, so it can be a really complex problem to deal with, and that's why we researchers, we like, oh, let's avoid all of that. Let's just assume perfect information. Everybody knows everything. It's just much easier to estimate models.
Fernando, just to kind of make sure that I understand the problem setup. So you're kind of thinking of a scenario where I go to an expensive neighborhood, see like a lot of awesome green spaces. And so I automatically assume that the crime rate in this neighborhood is lower than it actually is. And so because of this incorrect belief, I'm actually willing to pay more for this neighborhood, but not because I value the green space per se, but because I think that the crime rate is lower, and my willingness to pay is actually for the lower crime rate. Is that correct?
That's correct, but let me just split up a little bit what you said. I'm only talking right now about you know, from our perspective, trying to estimate people's preferences. We care about that for a number of ways because, you know, we do counterfactual policy, the predictions. We want to get the model right because of a number of reasons. A second reason is individuals, when they make their own decisions, and that's the example that you mentioned. Absolutely, they don't have the perfect information. Their decisions may be wrong and subpar, and they may have a lower welfare. What welfare is just well-being, that's saying economics, just because of that. It's like the example that I said about the students. If one friend of mine said that Tribeca is great, I'm gonna follow that, even if I didn't get all the data, even if I didn't process everything. So, but this type of bias and or heuristics that people use to choose can take a number of forms, because this kind of product, this neighborhood product is a really, really complicated product. But that's correct.
Thank you.
Okay. So now I'm gonna do an extra simplification, but it was not even needed here. It's just for the notation. You can bunch now all the unobserved terms in one Kc ij. So before here, I have this Kcj plus this delta omega ij. I'm just gonna bunch both together in this Kc ij, which is a neighborhood by individual unobserved quality index. And just to emphasize that now this covariance of Cj with Xj with Cij is a seemingly intractable problem, because it's just too complicated. It can take many forms that we're not aware of, which means that our models here that care about estimate those betas are likely biased in a number of ways that are hard to deal with. Now, we'll deal with this problem in this paper. At least we are claiming it. You'll tell me at the end if you'll be successful or not. And we're going to do it in two ways. We're going to estimate this model of individual neighborhood choice. And we're going to use the data that we collected from this program, this neighborhood choice program, and has repeated choice data. For every single individual or sample, we're going to have choice data before we present them with better information, and after receiving that information about certain amenities. And there's a literature in economics that does that, try to use this individual level survey data within those structural models, these choice models, in order to estimate those betas, those preferences. So yeah, I need to describe this choice model, where the data is coming from. So I'm not allowed to give you the name of the school, because the dean of the school is still looking at the paper to see if he'll allow us to distribute the paper. So he allowed us to present it, but so he wanted to see the results of the paper first. But the school, as I said, was really concerned about two items, and we're focusing those two amenities right now. One is cost of living. Remember, this is all pre-COVID, by the way. So pre-COVID, we really cared about rents being too expensive, especially in San Francisco and in New York. And the students really cared about maintaining their professional and social network, because it's important in the short term and in the long term. So the school cared about, and the students cared about those two things, and we'll focus the paper on those two, let's call them amenities, the price that you have to pay for the neighborhood, and the amount and the share of the professional and social network that live in a neighborhood. So we created this program that was implemented in April 2018, again, pre-COVID, and it's 2 months prior to the graduation of the students. So the dean sent an email to this big cohort of more than 800 students introducing this new program. And we gave the students an Amazon gift card, and there was a 41% take-up rate. And that's the timeline of the survey. First, they had to choose an MSA, and we provided them with 20 MSAs. I'll give you the name of the MSAs in a second. After that, we presented them with a list of neighborhoods in the chosen MSA. Each MSA had an average of 19 neighborhoods. It took us like 6 months to put together this list of neighborhoods. It's a really complicated process. And out of those 19 neighborhoods, most students only cared, and they said that they were only considering 5 or 6 neighborhoods. And in economics, that we call consideration set. And that's before we provide them any type of information, just to know what they're thinking, how they're thinking, what they're considering. And those are the 20 MSAs that they had the chance. So if they're living somewhere else, then they are out of the sample. Okay, so think about students going to live abroad in London. They are not here. But most students are going to New York, 43%, and 20% are going to San Francisco, and the others are going to a variety of places like Boston, Chicago, DC, Philadelphia. Those are the average number of neighborhoods that we presented then. New York had the largest, 25, because it's really dense. There's lots of neighborhoods. But most neighborhoods they don't care about. The actual neighborhoods chosen at least once by a student is a much smaller number. Okay.
Fernando, can I ask a question?
Yes.
Why does the consideration set change so much? Like for some of them, it's like 20%, and for New York, it's like 24 out of 25.
Part of it is number of students choosing MSA. So the more students you have going for one MSA, it's more likely that a neighborhood will be chosen at least once. That's all.
Oh, I see. Thank you.
But on average, because let's say Baltimore, I think only one person chose Baltimore. So in that person is listing 5 neighborhoods.
Gotcha. Thanks.
But this for New York, this is it's 43% of the people. So I have a lot of people here. So it's just the way I construct this table. But that's a good
Fernando,
point.
Kind of a related question. Is this kind of a hypothetical question where you rank a list of neighborhoods given to you based on like the information provided, thinking if they're attractive or not?
That's the beauty about this. All those the lab experiments have this criticism about the hypothetical question. Those are the students that they're about to graduate. They already, for the most part, already found jobs in that MSA. They're going to move to that MSA, and we tell that, wow, congratulations, you're graduating. tell me where you found the job. You're going to move to the MSA. Tell me the neighborhoods that are considering right now. And later in the survey, we ask about what part of the search process that they're in and lots of other things. So that's why that's a beauty about this program. It's not just, oh, let's think if you're going to buy a car today, what would be the car? You know, it's like, oh, I don't care about the car. I'm not buying a car today. It's like this, they are actively searching at that point.
Thank you.
Now, this is very important because there is a difference between stated preferences in a hypothetical scenario versus revealed preferences. Now, at that point, we also ask them to report their best estimates for the rent of the average neighborhood that they're considering, only the ones that they are considering, and what they know about the same school network in that neighborhood. And more precisely, that's the share of the same school peers from the past cohorts that actually live in that neighborhood, okay? We ask them, you know, what do you think in this MSA? What's the share of your friends or people that graduate from that same school that live in that neighborhood? So let's see if they get it right or wrong. For rents, most of them get it right. This is a deviation of their own perceptions and the actual rent. And most of them are around zero because, I mean, there's zero errors. It's like 30, 40%, okay? So they, for the most part, they get it right. But a lot of people overestimate and a lot of people underestimate, okay? It's a lot of variation.
Is this an error? Is this an error in thousands of dollars?
Yes. So one means 1,000
per month. So, for month rent.
For monthly rent, some people get really wrong in both directions.
Some people are way off.
Some people are way off, but most people are right. Yeah. Okay, so, but this is how the average rent error. This is the average rent error versus the actual rent, and each dot is an average for people, you know, for neighborhoods around 1,000. This is the average for neighborhoods around 2,000, and so on. It turns out that for the inexpensive neighborhoods, they tend to overestimate a little bit. It's $140. But for the more expensive neighborhoods here in the $4,000 or $5,000 range, they tended to underestimate rents. Okay, that's one of those examples of errors that people make that I was, you know, talking to you in the beginning. And of course, there's variation by person. Huh? There's a lot of variation by individuals here because this density at the individual level. But on average, there's also neighborhood level variation in that error. So I have those two things happening. And then there's the same thing for the network. Most people overestimated the share of the same school peers that live in a neighborhood. And the average overestimation is 6 percentage points, okay? And it turns out that they tend to overestimate more how many of your friends are there in neighborhoods that have more of those friends to begin with. That's the direction of the bias. Now, let me keep going with the survey. At that point, I know these results, but the students at that point didn't know their errors. At that point, we provided them, we shocked them with information. And for rents, we showed the Zillow rent index for the average house in the neighborhood. And for the same school network shares, we collected administrative data from the school. Okay, it's a lot of work to collect that information too. And that's something that took a lot of time, and I can't talk to you today about that. But then we tell the students, we show the students something like this. We show all the neighborhoods in New York. The most expensive is Tribeca, more than $7,000 a month in rent. The second is Soho, and we listed them in order. And the black dots are the actual data. And we show the students their own red estimates, the red dots. So for each student, we show, like, see, this is the whole distribution of rents in all those neighborhoods, and that's what you thought. those prices were. So they are aware of the whole distribution of rents, and they are aware of the mistakes they are making. And we do the same thing for the same school shares. So they like, oh, okay, this is the whole distribution. I didn't know about that. Oh, those are my mistakes. Okay, now I'm aware of that too. And then we ask them to re-rank those neighborhoods, to say, oh, now that you know this new information about the rents, and you know this new information about the peers, are you going to change your ranking? Are you going to change your consideration set? Are you going to change your first and second and third most, preferred neighborhoods? And we collect that data. And this is very interesting because, to be honest, the whole paper could be this 2x2 matrix here. Now we have the pre-rankings and the post-rankings. The students say, oh, this is my favorite neighborhood, number 1. This is the number 2. This is the number 3. And we know that before and after, we shocked them with the information. And this is for the variable rent. And in this corner here are students that they keep the top 3 neighborhoods as the same. So before and after the information shock, they kept the same neighborhoods, and these neighborhoods are usually expensive neighborhoods. The average price in those neighborhoods are $3,627. Now, there are neighborhoods that are never top 3. Those students are never choosing them, and they're cheaper. Okay, $3,000 on average. Now, this is happening because those always top 3 neighborhoods, they're better quality in many dimensions that we do not observe. And the students want to live in neighborhoods that are better quality, and they do not want to live in neighborhoods that are lower quality. Okay, think of this. This is the standard econometric problem of the unobserved neighborhood quality. Okay, that's why there is this persistence here for this particular school. Now, the other diagonal is the switchers. Those are the students impacted by the shock. They changed neighborhoods. Those are neighborhoods that they are not neighborhoods that are top 3 in the pre, but they are, yes, neighborhoods in the post. Students are choosing more those neighborhoods after the shock. And those neighborhoods are cheaper. Students are choosing neighborhoods that are cheaper after we shock them with information, 3,380. In the neighborhoods that are switching out after receiving are the more expensive ones, like Tribeca. Suddenly they realize, wow, Tribeca is really expensive. Let me get out of there. Let me choose another one as part of my top 3. Which for those switchers imply a negative marginal utility for higher rents, which is what our standard thinking, which is, well, I want the same neighborhood with a lot of quality, and I want to pay less. I'm better off under those circumstances. So those switchers are, in that case, they, higher rents, in theory, is something bad for people, and in practice, because you're spending more money. Now, we can do the same thing for the same school network share. And we find that those students want higher quality, which means more of this professional and social network. So they are always top 3 neighborhoods have a higher share, 7.7. On that, the average is 5 for this variable. And the never top 3 is lower. But the switchers are interesting. They tend to choose more neighborhoods with a higher neighborhood shares after we shares of the same school network. So have more of this network, a larger network. And they switch out of neighborhoods with the less of the network, less of the friends, less of the professional social network, which implies a positive marginal utility for the same school network, those positive preferences to live in those neighborhoods of higher quality. So basically, we can put this this is a linear regression. This is not my model. And this linear regression can include the fixed effects, control for demographics, individual fixed effects. And it's based on the switchers. And we find that the switchers want neighborhoods that are cheaper and want neighborhoods with larger network shares. And when you put those two numbers together implies a marginal willingness to pay for higher same-school network. And that's a parameter that will get out of the model too. But anyway, let me keep going. The survey doesn't stop there. We ask about the search process. We have we expose them to a mapping service. It's not Google Maps. It's our own thing here. That we provide this information about the rents and about the same school network, so they could access those maps during the summer while they're searching for their neighborhoods. Okay, that was the goal of this, and they're clicking or recording those clicks, and they finally chose where to live, the actual choice, and we also recorded that because the students are in touch with the school and we know what they finally chose at the end, which is nice. So this is going to end at 1 o'clock, isn't that correct? I have 10 minutes. I have to speed up. So estimation of this model basically is this. And we choose the variables that we use, the rent, same school network, a few census variables. But the key part is this unobserved stuff here. That's everything else that we can't control for. Now, there are two parts. We're going to come up with a proxy for this CIJM. I'm going to show that in a second. And we have this neighborhood fixed effects because we have two waves of the survey. And we can decompose those neighborhood fixed effects into some average components. And we convert those preferences into willingness to pay, which is preferences for the network divided by the preferences for rent. So those marginal willingness to pay basically tell you the dollar value that people are willing to pay for a better amenity. The rank order logit estimation, it's a standard estimation of discrete choice models. It requires that assumption that the people really can rank those neighborhoods and their utilities are ranked. So utility of that choice 1 is better than the utility of choice 2 and so on. And you can put together those probabilities of individuals I choosing a ranking R. In this functional form comes directly from that type 1 extreme value distribution. That's why that extreme value distribution is important. And we estimate it via maximum likelihood. It basically maximizes the probability that individuals are making their correct choice given what they revealed for us in those rankings, okay? And given those amenities that we have information. Now, it's critical to have this, to control in this model as another variable for this latent quality index, which is a proxy for that CIJ, which is this neighborhood by individual latent quality index. And it's critical that we have two waves of individual level information. And the first wave is what we use to create this index, is those pre-intervention rankings. Because according to our model, according to our theory, whatever the students reported, truthfully reported about their rankings, should capture all factors that influence that individualized utility. And that's what we used for proxy for this CIJ. And we follow a little bit, we have to adapt and improve the work done by this DAO 2002. And there are two main assumptions that makes this a valuable in a sufficient quality index. Again, if individuals truthfully report those pre-rankings, given their best knowledge about those neighborhoods, including the imperfect information. So we allow for the individuals to include their own individual imperfect information. And that when they change rankings after this program, that's really about the rents and same school network, as opposed to updating other things that we do not observe. Okay. And we can talk, if you have questions about that, we can talk about later, or feel free to send me an email if you have questions about this, because you really need to read the paper. The paper have many pages about that, and those are really important points. Now, here is some data. We have 390 individuals, 50% of them are female, ages 29. First gen minorities 15%, married with kids 12%, international students 23%. Those are the neighborhoods. It's a 5% same school network share. Rent on average is $2,470. Okay, and this is the consideration set. Those are our main results that only use the survey. I'll show us the results for the actual choices. When we do not include that latent quality index in the model, we have, this is the main problem for those models. The rent coefficient, which is usually the most important coefficient in this model, because price is usually the most important variable. It's not statistically different than 0. And it's biased towards 0. And it's biased towards 0 because once you do not control well for this unobserved neighborhood qualities and the unobserved imperfect information, all those covariances may bias this rent coefficient towards 0. And when we divide one coefficient here by the other, we get this willingness to pay that's too large and not statistically different than 0 anyway. Now, this is our final model in column 2, where we do include that latent quality index. And now we have this rent coefficient that's not biased towards 0. It's already statistically significant. And when we convert those estimates here into dollar values in how much people are willing to pay to an extra amount of the network, a larger network share in that neighborhood, is 228. And I'm going to read here the interpretation of this coefficient here, this implied willingness to pay, which is students are willing to pay an extra $228 a month in rent to live in a neighborhood with a 1 percentage point larger network. And this is for an average rent of $2,500 and an average same-school network in a neighborhood of 5%. So you can decide if it's a large effect or smaller effect, but it's a more precise effect than not using our method, and it's a smaller effect than, again, not using our method.
So the main lesson, it seems like, tell me if I'm getting this correctly, it's not necessarily these values. It seems like the main lesson is the importance of accounting for ignorance. And yes, you're quantifying how big of a deal was a model with ignorance versus a model without ignorance.
And that's exactly like in this particular project, we're doing it for one particular variable as a proof of concept. Now, it turns out this variable we think it's important because there's a long literature of why, especially the young professionals and college students that are graduating and MBA students graduating, why they care so much about this professional social network. But yes, I don't have time to show you results for heterogeneity and willingness to pay, but it makes sense that the married, people don't care as much about that. We have a lot of robustness tests about the model, about a number of things. I'm going to skip that. We have the results why the neighborhood matters for those students. This is going to be my last slide, given that I have 4 minutes. Remember, we follow those students after the survey. We observe the mapping clicks. The mapping clicks follow the same patterns as the post-intervention rankings. And then they choose one neighborhood to live. They actually sign the contract and they go live in that neighborhood. And we collect that data, okay? And what I'm going to show you is that same 2x2 matrix. But now the post is opposed to one neighborhood is what they actually chose. This is the top one neighborhood that they actually chose. That's the yes, I chose that neighborhood. And the pre is that pre-ranking, whatever they had listed as the top one neighborhood. In lots of students, they kept the same. This neighborhood remained the same, and it's a pretty expensive neighborhood. Now, neighborhoods that are not top one are much cheaper. Now, we have the same issue here with the switchers. They're switching out, they're switching in neighborhoods that are cheaper, and they're switching out of neighborhoods that are expensive. So the same results that we found in the survey, just in the hypothetical that Luna asked, we are fine for their actual choice. So this information treatment also impacted the actual neighborhood choice of those switchers here. It's not everyone. The people always on top, they didn't change behavior because of our survey. They didn't change behavior because of our survey. The switchers changed behavior in not going into expensive neighborhoods, but going more into the cheaper neighborhoods. And the same thing happened for the same school network variable or neighborhood amenity or neighborhood characteristic. The students, they are switching out of neighborhoods with a smaller network and switching into neighborhoods with more network. So in practice, what happened is we don't have enough data to estimate our model of actual choices. But we can do the 2x2 matrix and say, hey, those results are the same, which implies that for a share of the population, we are able to improve their welfare and well-being because they're moving to neighborhoods with lower rent in the same or higher, larger network. So they're able to preserve their amenities that they care about, but going to neighborhoods that are cheaper. And because we showed that the whole scheduled neighborhoods, and we made it really salient, hey, you're searching to now, let's think about this. Here's the data. Now go about your business. Choose whatever you want. Keep clicking on those maps. We're gonna help you during the process by, you can go back to that information, and it had a payoff. Okay, but that's it. So maybe you have questions for me now. I'm happy to stay here for whatever, another 10-15 minutes if you have extra questions.
Fernando.
Well, thank you very much. Yeah, go ahead,
thank
Luna.
you very much. No, go ahead. That's fine.
I don't know. I didn't have a question. Like you go ahead.
Yeah, Fernando, if we go to the previous slide, I was kind of wondering if you tried running this with pre being the post ranking, and what would you say happened in that table? So like you would imagine that people's preference didn't shift so much after the information shock.
Yeah, it matches. So but that's the but then there will be no switchers. What we have is they keep their consistent preferences. But that's exactly right. Yeah, in the paper we're adding all of that. But this is the more interesting, because the idea is to show that results that we're getting for people that respond to surveys are the same results that we're getting for the people actually making market choices. They're actually choosing where to live, and we're seeing that.
But that's great, because that shows that it's not just people having beliefs and preferences that evolve over time when they're doing the housing search process, because you could imagine people starting off with like wanting to live in like the fanciest apartment and then realizing that it's not actually realistic. So they like eventually converge to like a more practical set of options. Yeah, but that's a great result. Yeah.
Just out of curiosity, Fernando, did you go into any of the other features with the same? Do you have a sense of the sensitivity to other features like transportation? And I know you said something about restaurants and that, but how do those play?
Yeah. No, this is really important. Ideally, in those surveys, this is a pilot project. Okay, we are thinking about expanding it for other amenities. Other decisions, such as choosing MSA or job choices, or in the academic literature, people are concerned about dynamics, expectations, other issues. Our framework is so flexible that we can use any of them. Now, for this particular pilot, that's why we included those other census amenities that includes, race, income, education. I don't have it right now, but we also collected data on bars and restaurants. And when we include it, then it doesn't seem to change in our results at all. But part of it is because we are, our models really identified the data from the switchers. If we do not have switchers, think about you have 2 data points for the same individual, but if those 2 data points are the same, that individuals are not changing, then when you think about including individual fixed effect, there's no variation because they're doing the same things before and after. So our model relies on people with imperfect information really changing their behavior, and we live off of that. If everybody's permanent, or if everybody already knows everything, then it doesn't work. And that's why we think that adding those other characteristics didn't do much, because people kept their same beliefs about those other variables. They didn't really change those other beliefs, and they're really acting on what we provided to them.
Yeah. So it's almost, you found the most sensitive marginal information almost they could get. Is that?
It's not obvious. No, rent is they're really sensitive to rent.
Right.
In this setting, they care about the professional network and the social. Some people, there's heterogeneity in what they care about. Maybe the people that have those permanent tastes in our data, maybe those are the ones that care about other things, like school for their kids if they're married, or other things. Those people didn't move at all in their preferences. We've seen their survey. And we see that those married people with kids, they actually had a little negative preference for a higher share of the professional and social skill network. Because why do I care? I care about other things. So there's a lot of heterogeneity in what people actually care about those neighborhoods. But our framework deals well with that, actually.
So if you were to follow up on this research, what would you add to this to try and get a fuller sense of the picture? It seems like there's a good sort of baseline here, but what would be next, out of curiosity?
We presented it for the first time, actually, 2 weeks ago, and we received a ton of comments, again, because this type of modeling is applied to so many settings that people are saying, wow, we have to make our settings a bit more flexible, because it's obvious that people don't know everything all the time. And so I think it's, hopefully this will trigger a lot of research in this area. And I think it's already triggering. But from my perspective, I want to expand more to different colleges, to people in different settings. It turns out that, there are other papers already trying to do this experimentation with really, really low-income people. In low education, they really don't know anything about anything, unfortunately. They have a really time gather information, process information. There's so many other constraints that this is obvious that they're not maximizing anything because they have so many constraints. So people are working in that area. For me and Maisy, we care. I think we want to keep focusing on this population of college students and young adults, because I think we cannot just assume that because Google exists and because Zillow exists, they'll immediately gather that information and process everything. I think they need a little bit more hand-holding.
Okay.
And I think we'll try to do some research along those lines.
Cool. Very interesting.
Also, well, then thank you very much, Fernando. This was fascinating.
No, thanks a lot. It was fun.